All right, for problem number 1, we want to select all the expressions that are equivalent to the following. We've got 16x minus 12 minus 24x plus 4. So what you want to do is you want to simplify the expression and then simplify each of the answer choices to see which ones come out to the same. That's all you're doing. You simplify them all to see who simplifies to the same idea or the same concept. Okay? So when we're simplifying, the first thing that we're going to do is we're going to focus on simplifying those like variables. So we've got that 16x minus the 24x. So if we do 16x minus 24x, that's going to give us a negative 8x. Then we're going to focus on the constants, the negative 12 and the positive 4. So we're doing negative 12 plus 4. That comes out to a negative 8. Automatically right here, I see an answer located here already simplified. Since that is already an answer, I know that B cannot be an answer because you can't simplify B any further. That's not going to work, so I can cross it off. So I just need to check to see if these can be simplified. Well, hey, guess what? I know that this is going to be a correct answer because it looks just like what I have up here. Negative 16x minus 24x, right there. Then I've got, oh wait, no, never mind. That's not the correct one. That can't be correct because that's going to come out to a positive 8. So that's not going to work. It'll come out to a negative 8x, but it'll come out to a positive 8 instead of a negative 8. So that's not going to work. So now I need to just check here. I've got 4 plus 16x minus 12 times the quantity of 1 plus 2x. So the first thing I would have to do is distribute that negative 12 to each of the components on the inside. So I'm going to do negative 12 times 1 and negative 12 times 2x. Negative 12 times 1 is negative 12. Negative 12 times 2x is a negative 24x. Okay? Then if I were to go ahead and rewrite, so I have my like terms written side by side, so I still have this 4 plus 16x here. If I rewrite, I've got the 16x and the negative 24 that are like terms, which comes out to a negative 8x. And then I've got this positive 4 and this negative 12. A positive 4 and a negative 12 comes out to a negative 8. Look at that. It's exactly the same. So A is going to be a like expression. A and D are all considered to be like expressions. Like expressions doesn't mean that they're all simplified. Okay, you might have to simplify them yourself first to see if they are alike. Taking a look at problem number 2, we're just identifying which statements happen to be true, meaning that they are equal on both sides. So you might have to simplify some things to see if they are equal. So for here, we have a negative that needs to get distributed first to this 2x and this 7. Remember, if you're distributing a negative, then everything on the inside changes to its exact opposite. So this really comes out to 7x plus 3 minus 2x minus 7. I'm distributing everything that's inside of these parentheses. I'm distributing that negative to each of them. So it changes it to an opposite. Then I'm just going to combine my like terms. I've got a 7x minus a 2x, which comes out to 5x. And then I have a positive 3 and a minus 7 that comes out to a negative 4. Oh, that's what we wanted. So yes, this is true. Taking a look at problem B. I'm going to distribute this 5 to the 2x and to the negative 5. That's going to become a positive 10x and a minus 5 when I distribute. So I now have 7x plus 10x minus 5. I want to see, is that going to be the same thing as 17x minus 5? I got 7x plus the 10x. That does come out to 17x. That minus 5 is all by itself. It has nothing to pair with it. Comes out to the same thing. That's a true statement. Okay, for problem C, I have distributive property, but I'm distributing a positive 1. So if I distribute a positive 1, does it change anything on the inside? Yes or no? Distributing a positive 1, does it change? No. Only changes if it's a negative or if it's a number other than positive 1. Okay? So this is all going to stay. I can get rid of the parentheses. Here, I'm going to write this over to the side so you can see it better. This is going to stay 1/2 x plus 3 minus 1/2 x. And I want to know, is it equal to the 3? So I'm just going to combine my like terms. I've got 1/2 x minus 1/2 x. What's 1/2 x minus 1/2 x? 0. Those are 0 pairs, are they not? They're identical coefficients, but of opposite sign. They are identical, but of opposite sign. So they are considered to be a 0 pair. So they are going to cross each other off, and all I'm left with is a positive 3, which is what I'm wanting. That is a true statement. All right, if I distribute here, I'm going to distribute a negative 3/4 to the 16 and to this negative 12x. Okay, so that 5x is not going to change at all. It's just going to stay a 5x. If I do negative 3/4 times 16, that's going to come out to a negative 12. If I do negative 3/4 times negative 12x, that's going to come out to a positive 9x. Okay, now I need to just combine my like terms. I've got a 5x plus a 9x. 5x plus 9x is going to come out to 14x. Then I have this minus 12. Minus 12. This is not the same thing as here. This is not going to work. So no, that is not a true statement. Okay? All right, again, we've got this negative that needs to be dispersed to each of these components. That 0.4x remains unchanged. 0.2x becomes a negative 0.2x. Positive 8 becomes a negative 8. Now we can combine our like terms. We've got 0.4x and a negative 0.2x. That comes out to a positive 0.2x. That minus 8 has absolutely nothing to combine with, so it just stays minus 8. That worked. All right, our last one. We're going to do 8 times x and 8 times negative 1. That's going to come out to 8x minus 8. Then we're going to do a negative 3 times 2x and a negative 3 times a negative 4. That comes out to negative 6x plus 12. And then we combine our like terms. We're going to combine 8x minus 6x. What's 8x minus 6x? 2x. Then we've got negative 8 and a positive 12. What's negative 8 plus 12? 4, positive 4, which is what we wanted. So these are all statements that are true, except for statement D. All right. The last one, Mrs. McDonaldson's class is planning a rectangular vegetable garden. The dimensions of the garden are shown below. We want to write and simplify an expression to represent the area of the garden. How do we find area if this is a rectangular shape? How do we find area? Length times width. That's all you're going to be doing. Okay, we're going to take the length and we're going to multiply it with the width. It doesn't matter which one you're labeling, length or width. It doesn't matter. So we're going to take the 6 and we're going to multiply it by the 1/2 x minus 7. So that just means we need to distribute. We're going to do 6 times 1/2 x and we're going to do 6 times a negative 7. 6 times half of an x is going to come out to 3x. 6 times negative 7 is going to come out to a negative 42. There's our simplified expression. Okay, while I was out, you guys had iReady that was assigned to you. There's lessons. There were several lessons in there. There's quite a few of you who did not get on, like, at all, which is upsetting to me. You also had IXLs. You had 6 IXLs. All of that is to be done and completed by the end of class tomorrow. You still also have material that we're doing today because we were supposed to test today, but since I was out, we obviously did not get a chance to get to it. So we're going to test next week on Monday. Yep, Monday. Or Tuesday, sorry, Tuesday. You're going to take a test on Tuesday when you return. I hate doing that, but we're pressed on time because, again, we were supposed to test on today. So we're going to test on Tuesday. We're going to finish up our material today. We're going to do a review tomorrow. You will have that review to use as a study guide. I will also post some study material that you can do over the long break if you want to. It'll be optional, not taking it as a grade. Okay? And then you will test on Tuesday, okay? Let's move on. Yes. You can when you leave class. Let's move on to what we are covering for today. We are just quickly going over the idea of translation. Translating word phrases into algebraic linear expressions. So you have these different words that we utilize for our translation words. Now again, we've discussed each of these words, each of these operations already multiple times when dealing with word problems. So now you are going to be taking the word problem and translating it into an expression. All right, so our translating words. We've got all of our words that we've discussed before for addition. I'm going to go ahead and highlight addition in orange for you guys today, only because when we're going through those word problems, those contextual problems, I want to highlight key phrases in there in orange so I know that it's a addition problem. We've got the word sum. I'm going to put parentheses around the sum because the sum is the answer of an addition problem, which means if you're doing anything to a sum, you'd have to find the sum first. The only time that we ever do addition or subtraction first is if it's in parentheses. So I want you guys to put sum inside of parentheses so that you know it indicates that if you find sum, it's a value that has to be done first. You're going to put that phrase in parentheses when you see it, especially if there's more than one operation occurring in that problem. Kai, hush. Okay, we've got together or all together. Obviously, plus, you're probably not going to see that very often. Add or added to, increased, and then this word down here, more than. What I want you guys to do right now in blue is you're going to put a star on either side of this, and we'll talk about it in just a second. Okay? With more than, if I say something like 7 more than X. If I say 7 more than X, 9 times out of 10, you guys are going to just write 7 plus X. And that would be wrong. It's 7 more than the value X. That means you are taking the value X and you are adding or increasing it by 7. So what we call this is an order changing phrase. We call it an order changing or order reversing phrase. This is order reversing. Shh. I know that you might get this real quickly, but there's other people that you're distracting when you make your little comments. It can be very distracting. It's also distracting to me. So please stop. All right. Subtraction. I'm going to highlight subtraction in my purple, so that way when we're doing our problems, any subtraction words I see, they'll go in purple. Difference. Difference is just like what we said with the sum. It's an answer to a subtraction problem. That means it is one of those problems that if you see you're going to do something to the difference, you need to do the difference first, then you'd have to put it in parentheses to indicate that you're doing that first. Okay, take away, you're not going to see that very often. Minus, you probably won't see often either because those are very simplistic words. Subtracted from, decreased, and then less than. Less than, I'm going to put a star by it as well, because less than is also order reversing. Now, it might not be as big of a deal with addition because, you know, addition is commutative. You can change the order of an addition problem and it still comes out the same. But you can't do that with a subtraction problem. If you change the order of a subtraction problem, it changes the sign. Right? 5 minus 1 and 1 minus 5 are not the same value. So the order matters when it comes to subtraction. So again, if I say 7 less than x, you need to understand that that has to be written as x minus 7. I guarantee you there's going to be at least 1 or 2 people in this class that you're going to get that question wrong. Guarantee it. Happens every year, no matter how many times I highlight it, no matter how many times I tell you and practice it, there's always somebody who gets it wrong. Please, 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 let me be wrong this time. Let every single one of you get it correct. I beg you. Okay? All right. Multiplication. Talking about multiplication. Multiplication are things like product. Product is also one of those answers to a multiplication problem, but we don't have to put that in parentheses because typically we multiply first anyway. Then you've got times, you got multiplied by, you got twice and doubled and then tripled. We already know that twice or doubled means that you're going to be timesing it by 2. Triple means that you're going to times by 3. Okay, quadrupled, times by 4, that kind of thing. Okay, then we've got division. Division, you've got words like quotient, divided by, taking half, taking a third, taking a fourth, a fifth, a sixth, whatever you want to call it. Okay? When you take half of something, that means you're going to be dividing by 2. A third of something, you're going to divide it by 3. Okay, keeping that in mind, looking at those phrases, what I want you guys to go ahead and do is problems 1 through 4, you're going to identify what operation is being showcased. There might be more than one operation. So you're going to highlight with your colors the operational words, and then you're going to translate it like I did with these examples. You're going to translate it into its algebraic expression. It should only take you 2 minutes at most. Go ahead and try it right now. Problem number 1. Okay, guys, what is the operation that we're doing here? Just tell me. Addition. This is an addition problem. So what's the key words that are showing addition? More than. Okay, so that key phrase, more than. So when I'm writing it, is it going to be 6 plus x? No, it's not going to be 6 plus x. Don't forget. This is order changing. It's an order reversing. That means we're taking the phrase that it's surrounding and we are reversing their orders. That means x is going to come in front, 6 is going to come in back, and it's just an addition problem. X plus 6. All right, twice x, operation. Multiplication. All right, keyword is twice. What are we multiplying by? 2, so it's just going to be 2x. Okay, number 3, operation. Thank you, Jeffrey. Multiplication and subtraction. We do have subtraction, which is going to be the less than phrase. Less than this phrase. Then we have triple a number. Triple means that we are multiplying. So if I were to write this down, 2 less than triple a number. Triple a number means that I'm multiplying by what? 3. So this phrasing right here is basically 3x. This phrase up here is just the 2. I'm taking this 2 and this 3x and I am reversing their order. So that means 3x is going to get written in front. We are then subtracting and we are subtracting the 2. So you should have had 3x minus 2. You're doing 2 less than triple that number. All right, 8 times the difference of x and 2. 8 times the difference of x and 2. Operations. Multiplication and subtraction, right? We've got times and we've got difference. Now, the fact that it says difference, I need to also understand that that is one of my parenthesis words. So I'm going to be putting this x in the 2 in parentheses. That subtraction problem is going to go in parentheses. X minus 2 goes in parentheses because I'm doing 8 times that difference. So I have to find the difference first before I can multiply it by 8. This is what it should look like. 8 parentheses x minus 2. Okay? All right. Go to your back page, your last page. Yeah, this was still the first page, right? The front and back of the first page. Go to your second page. So now we have it in context, some contextual problems. I want you to go ahead and write the expressions that are representing these contextual problems. Those were just phrases. These are in context. Go ahead and do that. Let me go over this first one, because here, when you guys are taking word problems, you're having to identify different components. Remember, usually when we're having a simplified expression, we have a variable, right? Sometimes we'll have a constant, which is a number that's being added or subtracted in a situation. Sometimes we might have a coefficient, which is a number that's being multiplied with your variable. So what you want to do with word problems, contextual problems, is you want to identify those kind of components. What would be considered to be a coefficient, a variable, and a constant. So if you're trying to identify coefficients, there are some really easy ways to be able to identify the coefficient, which is the number that's going to get paired up with your variable. Your coefficient, you can typically look for the words per, each, every, phrases similar to those. That's usually going to attach a multiplication problem to it. So here it says Kyla wants to buy a DVD player. She already has $25 saved. She plans to save $10 each week. $10 each. That right here, because of the keyword each, is going to create our coefficient. So 10 is going to be our coefficient. Your variable is also going to be attached to that per, each, and every. Okay, so our variable in this case is going to be weeks. Now, obviously, I'm not just going to write weeks as my variable. I'm going to have to pick a variable that relates it. So what letter do you think I might want to choose? W, right? Pick something that makes sense. Typically speaking, though, letters that we don't usually choose T because it looks like a plus sign. We don't usually choose O because it looks like a 0. Okay, there are certain letters that we don't typically choose. All right. Our constant. When you're identifying a constant, that's a one-time value. It's a starting point. It might be like a fee of some type of value. Okay, we look for those things, something that you already are starting with. So she already has $25 saved up. So we know that 25 is going to be my starting point. So now you just have to identify the operation that's going to go between them. If she's trying to save money to buy a DVD player, is she going to take $10 each week and subtract it from the 25 she's got, or add it to the 25 she's got? Add it. So our expression is 25 plus 10x, or W, 10W. Okay? do that for problem 6 and 7. All right, let's go ahead and go over it. So for here, I know that my constant is going to be the gift card that he has, because it's a value that he's starting off with. I know that my coefficient is going to be the 6 because of that keyword per, and that the variable is going to be the cases that she is buying, the number of cases that she's going to buy. Okay, so when I'm writing this out, if you're using a gift card, she's using a gift card, or he's using the gift card of $50, or she, when you're purchasing items, your gift card's going to decrease in its value. So you're starting with the $50, and then you're going to subtract $6 for every case that she's going to purchase. So if she purchases 9 cases, you're going to do 6 times 9 and subtract that value. Well, I mean, that would be in the negatives. You'd owe money, but or let's say 8. You purchase 8 cases, 6 times 8, that's 48. You're going to subtract 48 from the 50. Okay? That's how it works with gift cards. The money decreases when you use it. All right, taking a look at problem number 7. Jessie has 150 cookies to sell at the bake sale. She sells the cookies as 3 per pack. So she's starting off with 150 cookies. She's going to sell 3 cookies per pack, right? There's our per each or every pack. There's our variable, the number of packs that she's going to sell. It even tells us you're going to use P as the number of packs that she's going to sell. So you're starting off with the 150 cookies that she's got. She's going to split them up into packs of 3 and sell them. So that means you're subtracting it. So 150 minus 3P. Okay, what you're going to be doing now is you are going to log into your computer. You have a 18-question quizzes that has been loaded into Google Classroom. Remember, you get how many attempts? 2. If you do not get 100, you must do the second attempt, even if you only miss 1 question.